Perfect. Hi all. Good afternoon. My name is Manu Ravishankar, and it's my pleasure to welcome you to the Strategic Innovation Fund's Round 2 Show and Tells. We can move on to the next slide, please. Thank you. One more, please. Thank you. So today we're going to be hearing from a really exciting collection of projects, essentially looking to support the critical challenge of heat decarbonization. And as we know, heating is absolutely critical to the overall net zero strategy. It is 37% of UK emissions, including industrial processes. About half of it comes from space heating, and about 38% comes from industrial processes. So essentially, we have a massive challenge ahead of us to decarbonize heat in line with the net zero targets, and we've got some major milestones that we need to achieve over the next 5, 8, 10 years. So in line with this, we'll be hearing from 3 very exciting projects in SIF. So we'll start with Indus, which essentially is looking to support dispersed industrial sites and how to decarbonize them. Dispersed sites are critical. They account for more than 50% of emissions. And actually, sometimes they're overlooked in terms of the importance of decarbonizing them for the overall net zero strategy. And they do face a lot of challenges. So this project is looking at a really a collaborative and a systems approach to drive cost-effective decarbonization for dispersed sites, but also for the energy system. And then we'll be moving over to watt heat, which essentially is looking at, again, a very critical issue of unlocking thermal flexibility in homes, which, as you know, is critical for peak load mitigation. But it's also really important for us to make effective use of intermittent renewables as the share of that increases in the energy system. And of course, this is not just a technical challenge. And so the project is also looking at market gaps and market mechanisms and what the direction is for that. And finally, we'll finish off with heat risers, which is a project that is looking at multi-occupancy buildings, which essentially is something like 1 in 4 domestic dwellings, so a critical part of the building population. And the host of challenges that exist in decarbonizing heat in these buildings, all the way through to reinforcement costs, building upgrade costs, and coordination. And of course, how do we better understand them? And importantly, how do we develop solutions so that consumer segment does not get left behind in the transition? So an absolutely critical part of the heat decarbonization challenge. So essentially, as you can see, we have a really interesting collection of projects looking at heat decarbonization, but for 3 different consumer segments, and developing critical technologies, business models, and market directions to help us tackle this. Just a quick note about the show and tells. These show and tells, are a critical part of the Strategic Innovation Fund, and it's actually a really important part across UK in terms of our efforts on energy innovation. And it's really an opportunity for projects to talk about the great work they have been done, their key findings. It's an opportunity for them to influence, other people's thinking. It's an opportunity to spawn new ideas, and of course, it's an opportunity for you to challenge them through all the wisdom that you may have gathered in the sector. So, please do make use of the chat function by introducing yourself. We have had in these sessions people collaborating and partnering over chat, and then finally developing projects. So you might never know, you might find someone to partner with for your next project. And as these projects are presenting, as you think of questions, please do put them in the Q&A. I'll pick them up at the end and ask the presenters to come on video and answer these questions. So each project essentially has 15 minutes of presenting time and 5 minutes of Q&A. So at the end of that, we'll do a wrap up and present some next steps. So I think that's enough from me. I will now hand over to the Indus team, which is Lucas, Matthew, and Hannah, to talk us through the Indus project. Over to you.
Thank you very much, Manu. If we can move on to our slide set. So good afternoon, everybody. My name is Matthew Rhodes. I'm the project lead for the Indus project, which is a discovery phase project, as we all are, I think, this afternoon, sponsored by UKPN. There are 5 partners in the project, in addition to UKPM, Cameros, which is my company, M3 Mass, Amoresco, Peterborough City Council, and Guidehouse. And this afternoon's presentation will be delivered by me, Lucas Duvaris, who's the innovation lead from UK Power Networks, and Hannah Swinburne from Peterborough City Council. She's the lead principal climate change officer. And we're hoping she's going to join us, but she wasn't actually here a second ago. We'll see when we get there. Move on to the next slide, please. So the focus of our project is within the overall space of decarbonising heat and accelerating decarbonisation of heat. We're looking very specifically at industrial heat demand, and specifically within industrial heat demand at dispersed or distributed industrial sites across the UK, across the UK KTN's licence area, specifically for this project. The rationale for that, as Manu actually intimated in his introduction, there's been an awful lot of policy attention and funding on the kind of two extremes of the industrial sector in the UK, which is the one end, the heavy industrial sites like steelworks and petrochemicals. If you look at that left-hand chart, the ones where the energy intensity is well over 40 terajoules per £1 million of output. And there's also been a tremendous amount of attention paid to buildings, as we all know, which is, includes office blocks and covers the people at the top of that chart. So, and off it, but theatres, entertainment, hospitality, and general office buildings. But there's a whole space in the middle, which consists of manufacturing businesses, people like hotels and accommodation as well, but waste sectors, metal processing, which has been missed out. And typically we're talking here about relatively small operations, probably 10 to 50 people spread out across the country, and they account for 56%, as the chart on the right shows, of UK industrial energy demand or industrial carbon emissions. And that is then 17% of total UK energy demand. So we're focused really on that 10%, so half of 17%, or just over half of 17%, and how you do that. This is important to the electricity networks for two reasons. One is, as mentioned on the slide, that decarbonisation means switching off the gas and switching to electricity. So greater demand for electricity. How do we meet that? Are the networks strong enough? But also for this demographic, there are spatial consequences, because unlike steelworks or petrochemical plants, it's likely that as we decarbonise the economy, these types of operations might well move to where they can access lower carbon infrastructure. So there's a significant spatial dimension, apologies, a specific spatial dimension to the problem here, which of course is relevant to network operations. So we need to really, as networks, it's really important the infrastructure networks understand this demand, understand how it's likely to change over the next 20 or 30 years, and understand the nature of that change, not just in terms of magnitude and when, but where as well. So that's the basic problem we're trying to address. If we move on to the next slide. Yeah, so I'll hand over to Lucas now to give you KPN's perspective on this problem.
Thank you, Matthew. So I think Matthew pretty much covered what are the challenges from a network perspective. If you have all the sites decarbonizing in isolation, then this is going to have a huge impact to all the networks overall. And as a network, we are trying to be key enablers in the energy transition and not blockers. We don't want to say no to customers when they are asking for some capacity for a new development or for an upgrade in the existing development. So Matthew is going to talk to you about the Indus solution in a bit. Just at high level, it's going to be a solution that will be an offering from UKPN to industrial customers and developers to offer a path to decarbonization. But at the same time, it will be something that we're going to incorporate in our processes internally. So where we identify that there is a requirement for an industrial solution that will be more coordinated because of the Indus solution that we're suggesting here, then the investment needs will also be incorporated in the planning processes, and we'll know how to deal with the increased demand over the next few years. So as you understand there, we're talking about a product that will involve multiple parties. So it's not only the DNO that we need to understand the process, but we also need to understand what are the requirements and needs from industrial customers, and industrial developers. We also need to understand what are the challenges from the local authorities perspective, and we are trying to get all the people involved in such solution in the project in the alpha phase to have a holistic approach. So that was from me. I will pass over now to Matthew because I believe that Hannah had some issues with connection.
So if we move on to the next slide, yes, I think it's probably Hannah trying to call me a minute ago to say that she was having issues. So we've been doing this project focusing on Peterborough, Peterborough City Council as a local authority area, because as I'm going to explain in a moment, the strategy is to try and actually do one of these developments in a very specific place. So it's very important we engage with the local authority. Peterborough, a really good choice because they have declared a climate emergency. They've gone quite a long way down the kind of energy road in terms of a local authority understanding the issues. They've got their own solar farms and so on. So they're very into this agenda in general. They're also a growing economy with space to grow with some fairly meaty industrial activities. So there's a domestic appliances factory, Whirlpool, and Perkins Engines well established in Peterborough, and lots of growing industrial activity. So we've worked very closely with Peterborough throughout the project, and they're very, very supportive and enthusiastic about it. It's a pity Hannah can't be here to say that herself, but she would have said something along those lines. So let's go on to the next slide. Okay, so I'm now going to give you an overview of what we've actually got up to in the project and where we've got to and where the next steps are and how we hope to take it forward into alpha. So if we go on to the next slide. So we presented the problem in terms of a high-level challenge of decarbonising this particular demographic, these dispersed industrial sites across the licence area, and there are tens to hundreds of thousands of those across the country. The core hypothesis of Indus is that decarbonising those sites where they are is probably not the lowest cost solution for network customers. So basically you have to invest considerably in the network to decarbonise them where they are. If you group them together in clusters, it will cost less because you'll be able to optimize the infrastructure more easily. But that creates a whole range of new challenges. So what we've tried to do in this discovery phase of the project is really answer two questions. Firstly, is that hypothesis correct? So are there benefits from doing this? Intuitively there should be, but are there actually, can we identify those and can we quantify them? And secondly, if there are those benefits there, how can the network, the electricity network organisations in particular, make sure, as Lucas intimated, that they are supporting a process of making this happen, the lowest cost approach to industrial decarbonisation, rather than being a barrier. So that's the kind of two core things we were looking for in the discovery phase. We've gone to the next slide. Okay, so we had 5 work streams. The overall project strategy has been from the beginning to try and do this. So we learn by doing. What we're trying to do is actually cluster a bunch of industry together, identify the infrastructure it would need to be net zero, work out how the network can support that. And by seeing how replicable that is, we can quantify the benefits and so on. So that's how we're going to answer the problem. Those were the 5 work packages. We go on, I'll talk a bit more about what we did in work packages, which is more interesting. Okay, next slide, please. So every work package has contributed. It's been a really good project, interesting relationships and very constructive work between the 5 partners and UKPN. What this slide shows is some of the outputs of those work packages. So top center, you can see an industrial park. Just if you had any uncertainty about the kind of thing we're looking at those, and we're looking at how we develop those over the next 30 years for a net zero world and how the networks support that. On the left, you've got some work we did on how many of those are there, where is the best place to put them, where is industry at the moment. So we've got quite a lot of GIS mapping activity within the project where we've identified different types of industry, energy demand profiles and so on, all helpful to give DNOs a sense of where this problem is and where it might move to. So the spatial type work, and we've identified We think over the next 30 years, between 67 and 250 odd locations where these kind of parks will potentially develop in UKPN's license area. Over to the right then is some of the work done by Amoresco, looking at, given that this is what you're doing, what is the kind of infrastructure that would be deliver net zero on these sites? And they've come up with 7 generic types of infrastructure solution for the parks. And then at the bottom, moving towards the kind of benefits case and the how are we actually going to make this happen? That's a piece of work, really quite interesting piece of work that Guidehouse have done on all the potential regulatory barriers and mechanisms that might exist within the energy sector that might potentially inhibit getting there, so that we understand where they are. Positive outcome of that piece of work was it's far less challenging than, so that the environment's more receptive to this approach than we thought it might be. Okay, if we go on to the next slide then. And then, which is one of the more exciting slides, if you like, because this is the answer to the first question I put: is the hypothesis correct? The answer is yes, the hypothesis is correct. If you cluster these sites together and find a way of doing that and provide the infrastructure support, then we've identified an estimated £155 million of benefits to network customers from avoided reinforcement costs by clustering together industrial sites in the kind of way we're looking to do. So 33 million within UKPN's license area, and you can extrapolate that across the country. We've profiled it to 2050 using some of the various scenarios that are out there. And it's important to stress this is a first cut conservative figure. So we're looking only at avoided reinforcement costs, and bottom left there you can see a range of additional benefits that may well accrue, particularly on the customer side. So customers benefit from this themselves. They make their own savings that the energy system doesn't see. So we think we can get more, but we've got a good starting point. Okay, if we just move on to the next slide. The discovery papers have been really helpful to this project, and we've moved quite a long way without actually changing the core of what we're trying to do. So we're trying through the whole SIF process, if we can get to the alpha and beta stages, to actually intervene in one of these industrial developments. Sorry, that's me reminding me of the 15 minutes. To intervene in one of these developments and make sure and implement the solution we're developing. I think if I kind of jump to the middle of that slide, one of the things we've learned during discovery is how challenging the commercial development world is, or not challenging, but just complex, and getting into that at the right time in the right place is something which is very difficult to engineer sometimes, because there's a lot of game playing goes on actually there. Local authorities are really important. Economic development agencies are really important because they control the big picture here, the spatial planning, where people are likely to locate their industrial plants, and they can influence that to some extent. But the big lesson is the power here of the DNO, if they are able to kind of come into this market with a solution that is particularly designed for this kind of collaborative industrial decarbonisation. So the big difference between the Indus type approach and the business as usual is the business as usual is all framed around individual customers, individual industrial entities approaching DNOs for connections or enhanced capacity or whatever. And it gets in the way of those companies collaborating with their neighbours to come up with a lower cost way of decarbonising, or a faster way of decarbonising, or a more efficient way of decarbonising, particularly from the infrastructure provider's perspective. And they're never going to lead that kind of solution because it's too difficult for them, let alone dealing with a DNO that only deals with individual customers. So there's a real opportunity here for DNOs to go into that market and say, we actually have a solution. If you're prepared to do A, B, and C, then we can do D, and the whole of that will save everyone money. So that's a really powerful thing, and we're going to build our alpha phase proposal very much around that, and then test it on the specific development we're hoping to identify in Peterborough or the wider UKPN license area. We also learned quite a lot about data, of which there is a lot. organizing it in a way that's meaningful to planning, identifying these sites and all the rest of it is quite a big task. We think there's serious value in developing a methodology that could be applied across all DNOs to understand industrial energy demand and identify sensible solutions for that. So that's the final lesson. And I think if we move on to the next slide, my final one. So in the alpha phase, we're applying those lessons. As I say, we're building it around work package 2, which is developing a DNO solution for Indus type industrial parks. And Amoresco, then work package 1, will be working through an investment case for one of the industrial parks we'll be working with, or the industrial park we'll hope to work with in the beta phase. And we've already got a short list of about 10. The other work packages all support that and make sure we go to market with a sensible product. Thank you.
Great. Thank you so much, Lucas and Matthew. So I think we'll go into the Q&A. So I think I'll start off with this question from the audience, from Maxine, a really interesting one, which is kind of going around my head as well, which is, would there be scope at some point to also look at implications for gas networks? So rather than just kind of power networks coming forward with a solution, is there some integrated approach where gas and power networks comes together? And I think she's just made a note also that that's perhaps useful for industries, but also as gas networks are figuring out their, I guess, future role in a system transition, that also might be a more coordinated way to kind of think of their role. Like, yeah, have you guys given any thought to that?
Yes, shall I answer, Lucas, and you can maybe come in and add anything to it. But absolutely, we have. I'm pleased to say that Cadent Gas have agreed to join the bid for the alpha stage, so that we can build that into our approach. There's clear interactions, because some of these companies need gas and they can't be decarbonised by electrification. That was a simplifying assumption that was floating around in the policy world for quite a long time, which was basically the only people it's difficult to decarbonise from difficult to electrify are steelworks who need a bit of coke and petrochemicals and so on. But actually there are chemicals plants that are quite small, aluminium foundries and brickworks and people like that who need gas. So they can't electrify. They do need hydrogen. You then have a question how you get hydrogen to those sites. You can ship it into those sites. You could also generate green hydrogen on site, which would mean electrolysis, which means electricity again. So, you know, there's very, very clear interaction. It's a really good question.
Thanks, Matthew. Lucas, do you have anything to add?
No, I think that Matthew covered it pretty much. We would like to work with Gas Network because of the experience that they have in the sector. And we're actually, as I mentioned in the beginning, we're trying to engage with all the different players that are involved in this kind of solutions. That's why engaging with a gas network, it's really vital for the project, because some of the solutions will involve gas as well. Some of the future solutions will involve gas. I'm talking about the solutions that were developed in the pattern book that Matthew showed really briefly before, but all can be found in the deliverables and the end of phase report as well.
Thanks, Lucas. So we've got a couple more questions. One from Ben, which is, I guess, a more kind of analytical question, which is, could you maybe give a little bit more information on how the energy needs were assessed to, when you then look at the infrastructure opportunity or the decarbonisation configuration opportunity? Did you do like a different profile of industrial commercial sites and then you built them up? Was that kind of how the analysis was done?
Yes. So yeah, so we have data by SIC code. So we have standard data sets for the split of industrial demand by SIC code. So for example, if you take I don't know, a steelworks or a manufacturing of, it would be manufacturing of cast metal products or something like that. We have data which shows how much energy in that sector is spent on buildings, how much is spent on high temperature processes, how much is spent on low temperature processes, etc. So we have characteristics by SIC code. Interesting aside, in fact, on one of the early slides, in these kind of businesses, 90% of the energy is process energy, not building energy. So just kind of reinforcing my early point that solving buildings does not solve industrial energy demand. So that's the short answer is yes, and we did it in the way I've just described. That is a very kind of statistical way of doing it. We blend that with a bottom-up way, so we use that to identify kind of high-level potential for Indus type solutions or locations and bringing people together, or the right kind of people together. But the actual methodology, if you like, requires the engineering team, in our case Amoresco in this project, to look at the actual energy demand. You've got to get into the detail of the individual operations of the individual companies in the actual industrial parks to optimize anything from a network perspective or from an industrial park perspective. And we're trying to generate, I guess, a solution or an approach that can accommodate that need for very specific local solutions without making the solution so complex no one can use it. So there's a path to be trodden.
Thank you so much. So I think Ben says it's very applicable, and he's going to reach out to you regarding another project. So that's great, and that's exactly what these sessions are for. That's great. I think just an observation from Rob rather than a question, that I guess kind of energy as a service type offering is a really interesting attraction to industrial parks, but that's generally the reason they're kind of situated somewhere, because it gives you access to kind of critical assets or services. So this is a really nice proposition. So I think that's just a comment. Just one, I had a couple of questions. Actually, on the commercial side, I'm really interested. Like, I mean, Matthew or Lucas, do you see essentially that there's like a special purpose vehicle or something similar that sits on top of these parks, that then there's kind of a single legal entity that then engages with networks, for example? Is that kind of how it might potentially work, rather than so many individual entities?
Yes, is the again the short answer. It might work that way. I think it's about kind of facilitating the path to that kind of outcome, that kind of commercial outcome, and making that the natural way of developing these kind of parks. Because without, I mean, like many things actually, in my experience in the energy system, or the UK energy system anyway, almost anything is actually possible, including probably very flexible industrial park developments with optimized infrastructure. So it's theoretically possible from an engineering and a commercial perspective, but practically it's virtually impossible to make happen because the business models of all the participants, and including the DNO and probably the gas networks as well, make it very, very difficult for those outcomes to occur. So one way of looking at Indus is really making it much easier for people to set up those kind of vehicles, because it simply becomes naturally the sensible thing to do when you want to develop an industrial complex in the UK.
Thanks, Matthew. I mean, one question to Lucas. You know, there's always this kind of chicken and egg situation, especially on sectors that are still figuring out their decarbonisation trajectories, in terms of, will they figure it out and then the infrastructure will come, or do you make strategic infrastructure choices and then they'll figure out how to decarbonize? Like, does this approach start to help you kind of break that cycle a little bit? Is that, you know, do the networks now think of a configuration, or is there a way of this industry is working through this and then a more coordinated approach to infrastructure development happens? Like, yeah, does it kind of help break the cycle a little bit?
I think you're right. So a reason why we are actually dealing with this project at this point is because we are trying to influence the decision making when it comes to industrial decarbonization in a good way, of course, that is applicable not only for the industrial customers and cost effective for them, but also for the DNOs, because it will also help us to identify where you need to invest in the future, instead of just a customer coming to us and letting us know that they need a really, really high capacity for the next couple of years. So we are trying, as I said in the beginning, to be key enablers in energy transition. That's why an Indus solution, even though the decarbonization of the industry, I don't think it's something that we'll see a lot in ED2, is actually having the tools in place prepare us for ED3 onwards. So this is how we actually see it, and also maybe also transform the business internally and how we work, because as of the 1st of April, we have established a DSO, which is a different entity. And for example, within a DSO, we have a new team that is focusing on local authorities and how you can help them decarbonize. So why not develop something similar for industrial users in ED3, for example? So this is another idea that we might have for the solution in the future.
Brilliant. Thank you so much. I think that's the end of the Q&A, and I think it's really interesting to see, and I think really exciting project, which kind of hits that barrier, but also more broadly what kind of dispersed sites need quite critically, I think. So thanks, Matthew. Thanks, Lucas. Really appreciate your time presenting and taking questions.
Thank you very much.
Thank you, Manu. Thanks everyone.
And we're going to move on to the next team from What Heat. So if I can ask Farhan and Hannah, please, to come on video. Farhan, am I handing over to you?
Yes, thank you.
Over to you.
Hi everyone. I'm Farhan Dari. I'm part of the Baringa team, and I'm joined today with my two colleagues, Hannah and Ben. What Heat was a project that is sponsored by UK Power Networks as well, and our partners included Passive, GLA, and Tapio. I will talk a bit about their roles towards the end of the project, but let's go into the problem statement. If we can go to the next slide, Manu, please. So as Manu mentioned in the beginning of the call, decarbonization of heat is an area of challenge when we look at domestic heating, especially. There are several scenarios for decarbonization, all of which include a significant amount of heat pump installation. The government has the ambition to increase heat pump installations from 35,000 to 600,000 by 2028. This extra demand for electricity, in addition to other assets such as electric vehicles, are going to significantly impact the peak load demand that typically for a small household right now is 2 to 3 kilowatts to about 5 to 7 kilowatts. The increase in peak demand really means increase in reinforcement. But if the demand was flexible, some of the costs needed for reinforcement could be either mitigated or deferred, as we can see EVs starting to play that role a lot more. Now, when we look at heat demand, this becomes a lot more challenging because it's tied to a lot of people's habits and needs. So it really needs to be, heat needs to be present when people want it, and some of these assets we need to figure out how they can be operated. There are a lot of trials going on currently that are looking at flexible operation of heat pumps with or without storage assets. Heat storage assets are relatively untapped, especially because the market mechanisms and customer appetite for them hasn't been existing so far. So in What Heat, we were really our aim was to tap into this area and really understand the technical aspects as well as the market aspects. More specifically, within the discovery phase, we wanted to, first of all, consolidate the data that already is out there, look at the technical feasibility of some of the technologies, old and new, that are in the market, and what level of flexibility they can provide, and understand the business case for this technology. Is really what is the value to the system and to the customers that these technologies can provide, and are they worthwhile for domestic customers. If we could go to the next slide, Hannah will take us through our approach. On to you, Hannah.
Hello. So yeah, as Farhan said, we thought about a number of technologies as part of What Heat, including heat pumps with kind of smart hot water tanks, but also kind of more novel solutions like large space heating primary thermal stores, which are effectively just really big hot water tanks that allow you to shift your space heat demand as well as your hot water that you use for kind of like showering and stuff. But we also considered especially innovative technologies like Tepio's zero emissions boiler, which can actually, because it has the storage capacity to store a whole day of space heat demand overnight, can fully offset the power draw from heating away from the electrical draw, whilst it also has another benefit of being a direct replacement for a conventional gas boiler. So some of the challenges for heat decarbonisation are overcome by that too. So when we were kind of going about modelling this, we thought about separate heat and hot water storage capabilities, which was really important so that we could consider the difference between a peak winter day when it's like super cold and your space heating's at its maximum, but also the more classic day, for instance, today, where you're probably just going to use hot water and not even think about turning your heating on. So we were thinking about the technologies providing kind of different layers of thermal flexibility, ranging from building inertia, which is a very simple assumption that a well-insulated house, we're talking like above EPC C, can be preheated before your conventional heating hours to enable the consumer to have lower energy prices, but also some of that peak power draw, which would happen at peak power hours, to be shifted away from those hours, which provides system benefits as well as consumer benefits. So for each combination of technology, we modeled a 24-hour power draw profile on different types of days. So we were thinking about the technology operating conventionally, which we defined as operating to meet heat demand as and when it's required in the house, and then comparing these operational profiles to that technology flexing. So kind of maxing out its flex potential. So the graph on the right of this slide highlights one example of this, which is for a heat pump with one of those big primary thermal space heating tanks, which allows the space heat demand to be shifted. So you can see in the dotted line, we're operating in peak hours. So that's the conventional operation of the systems. Whereas when you think flexibly, you can actually store some of that heat demand overnight and in more off-peak hours in the afternoon to enable a decoupling of the peak electrical power draw from the conventional peak hours, which is really valuable. We modeled the flexibility potential of these technologies, but also found through our research that currently the market mechanisms and incentives don't really exist for providing great revenues from this. And hence Farron's going to talk a bit more about how we valued this electrical shift capability from the technologies into flexibility potential.
If we can go to the next slide, please. Thank you. Like Hannah mentioned, we assessed that there is great flexibility potential with these technologies, but there's also obviously a cost attributed to each of the technology combos, especially the ones that provide larger amount of flexibility. And now to create a business case and incentive or any package that makes these combinations attractive to customers, we need to understand what the value is in terms of revenues, bill savings, and overall system benefits to really incentivize all the different parts of the value chain. So to do that, we looked at each of the technology combinations first separately, and looked at the savings that can be achieved per household by taking advantage of time of use tariff through the flexible operation of the assets like that Hannah just explained. In addition, we looked at the potential for the technology in participating in value streams such as DSO sustain. TOU and DSO sustain together already provided a robust revenue and cost saving stack for the customers, but we went a step further and looked at the potential upside from dynamic curtailment and capacity market participation through aggregation that could really increase that revenue stream further. Our analysis showed that for all of the technology combinations, there's a reasonable payback period of something around 10 to 12 years for the most expensive cases and below. And if we look at more specifically around these revenue streams that make up for that payback period, we can see that for the zero emission boiler options, because of the large flexibility capacity of the asset, you can tap into larger revenue and returns. However, some of this will be offset by the higher operating cost of the asset, as it's a direct electric source and has a lower efficiency compared to a heat pump. The next step we took was look at the aggregated value of this across the UKTN patch to see what are the system benefits. We assigned different technologies based on their suitabilities to housing types across the UKPN patch, and found that the flexibility of the assets, the flexible operation of the assets, could deliver about 8.8 billion pounds by 2050. But of course, this value varies region by region. And that's what we're trying to show on the graph on the right-hand side. When we looked at the regional variability, we came to very interesting results. We found that if you compare constrained and unconstrained areas, you can get a different value stack of around 200 pounds, which in a way is additional incentive for households that are within those DNO constrained areas to install these assets. But there is a bankability issue associated with that due to basically the reinforcement need being met through network reinforcement and works. So that needs to be looked at. There was another element, and that plays into this, that makes it a bit of a challenging area that needs further consideration, and that's equitability. Basically, the difference between constrained and unconstrained areas means that some areas could end up with issues like the postcode lottery and being able to get more money compared to another area that is not within a constrained area. These are some of the challenges that we saw that we want to look more into in Alpha. And I think that's a good segue to go to the next step. If you could go to the next slide, please. So as for the next steps, we envision Alpha to have 3 high-level objectives. The first one is looking and defining that DSO service potential in more detail. How will a thermal storage, domestic thermal storage asset participate within a DSO service? And how can we design incentives and packages that can help with mitigating some of the issues around inclusivity and the bankable issue? And in addition, we found that there are more benefits from having a diverse load for heat demand that could potentially help with some of the connection challenges and impacts of cold start, which is a big problem in the more decarbonized scenarios. The second objective would be to look at the interaction between the different services, as well as the interaction of the different technologies. So how do DSO and ESO services combine and interact in addition to the use of time of use tariffs? How does a system need to create the highest value opportunities for the customer, and also understand what with the variability of the technology combinations, what will the impact be on the network? The last objective, which is the most important one and a true enabler, is the customer propositions. So in Alpha, we want to dig a bit deeper into customer needs and appetites around thermal storage, really using the value from the research that is already out there and adding to it. Looking at how we can create a market that is attractive for domestic customers to participate in through various propositions and incentives. And lastly, how can we really create that investment case? Across all of these objectives, of course, we have the regulatory barriers and enablers that we need to look out to. As we know, the regulatory landscape is changing to be more, allow more of this flexibility and the incorporation of such assets on the network. So we plan on incorporating that change as we go on through the phases, and also add to some of the decision making that is happening at the moment. If we can go to the next slide. I think we're bang on time. Just on the last point, I wanted to thank all of our partners, UKPN, Passive, Tapio, and the GLA. It's been a great collaboration, but also point out that we are currently in engagement phase to recruit more partners for the Alpha application to help us build some of the customer proposition and trial propositions for the next phases. Thank you very much.
Super. Thank you so much, thanks, Hannah. Yeah, great presentation. So I think I'm still waiting on questions from the audience. So maybe I'll kick off. Which, I mean, just as a kind of clarification question, really. When you talk about flexibility provided by thermal storage, do we mean the thermal storage itself kind of charges to charges, or do we mean the heat pump or the zero emission boiler operating flexibly to kind of change the power load, and then kind of heat is stored so that there's a smooth heat output, but then the power output, just for clarification so that I understand.
Yeah, exactly. That's how we modeled it. We modeled it on the assumption that the heat demand of the customer is not changed, the power draw is changed. So the basis of our design was not compromising the heat demand of the customers.
Understood. So just maybe then a follow-on question. Then have you considered? I guess you had a list of, ISO's heat pumps, a zero emission boiler, etc. In terms of their own flexible operation. Have you considered their capability to kind of modulate as a factor in your kind of criteria assessment?
Can you clarify what you mean by that?
So if you're not running the heat pump on a kind of same output, you're kind of moving the heat pump load up and down, or if you're running the zero emissions boiler or something else, I guess all of the technologies have slightly different ways they deliver heat if you modulate them, or their lifetime, or their cost of operations or maintenance. Is that considered in your?
Yeah, that's exactly what led to the different revenue stacks and really return stacks of all the technologies. It comes down to their capacity to store the energy, capacity to shift, and the hours that they can shift, which is basically for how long they can maintain, they can keep the energy, like their installation levels, for example. Hannah, if there's anything to add to that, please feel free to jump in.
I mean, I'll probably just add one thing is, I guess what we didn't do is look at, for instance, modulating a heat pump up and down without a thermal store involved. I guess in any situation, you've always got the thermal inertia of the building, which is the sort of baseline thermal store we considered. But our scenarios were more about effectively how many hours of decoupling can you get through using the thermal store. So it was almost, if you had a heat pump, what would the incremental benefit be of buying a thermal store to work with it, and what additional payback could you get from that?
Got it. Yeah, thanks, Ben. Yeah, I think that's kind of what I had. Good to clarify. Thank you so much. And I think the question from Maxine, which I think you just touched on, but it'd be good to clarify. Are you assuming an EPC-C? And is there any value in energy efficiency to increase the scope for flex? I think you assumed in all your scenarios you're highly energy efficient buildings, didn't you? Is that?
might be one for Hannah.
Yeah, we are assuming EPCC, which is an optimistic assumption, because to enable a heat pump to be installed, you really need high energy efficiency because they operate at lower temperatures. And so, yes, we are definitely uplifting EPC ratings to EPCC is a kind of precursor for heat decarbonisation.
But I think that was one of the reasons we did that was, well, A, to simplify in the time we had, but B, also there's a study just published by the Citizens Advice Bureau looking at energy efficiency and the benefits of that. So we felt we would just hold ourselves constant at EPCC, but you're right in that investing in additional insulation could provide incremental benefits against that base case of just the heat pump with the building inertia.
Good. Thank you. Just a final question. It looks like the kind of revenue stacking is critical to make it work for the customer. And I guess there's also a kind of investment certainty. If you were to invest in an additional asset, what's the certainty you're going to get back investment? So are you going to look at potential commercial models like kind of no capex upfront, or maybe even a utility funded is that kind of where you're thinking? Is that how do you make the consumer proposition work when there's uncertainty in revenue potentially?
For sure, and that's exactly where this concept of bankability came from, and looking at the DSO incentives, in that there are trials out there looking at individual technologies or looking at individual revenue sources like time of use individually or ancillary services individually. But we generally found that there's not a lot looking at DSO services, and there's not a lot looking at the combinations of those incentives together. And combinations of technologies in an area under a substation and how they might conspire to cause problems for the network, for example. And so this issue of the DSO services revenue, Farron showed that chart of the difference, the £202 difference between being in a constrained or unconstrained area. There is a challenge there that that additional £202, whilst there's a fairness issue of where do you happen to live, do you get access to it or not? Equally, if you're an investor or a supplier looking to provide capital for one of these solutions for a customer, you don't really know how long that £202 is going to be available for, because as soon as the substation is reinforced, it goes away. So is that incentive actually even bankable for investment? And so that's where we want to take this next, is understanding the combinations of these factors, and then how do you build a proposition that works for the consumer, but also for whoever's putting the capital down, if it's not the consumer themselves.
Yeah, really interesting, Ben. I think those are the kind of critical things to crack for Thermalflex. So yeah, glad you guys are looking at it. So yeah, thank you so much. There are still a few more questions, but if you don't mind maybe typing an answer to them, that'll be great. Thanks again for the presentation. I think we'll move on to the next. I think we're going to retain Hannah and Ben for this presentation. So I think we'll move over to heat risers, which will be the final presentation of the session. So over to you, Ben. By the way, just like your voice goes a little bit faint at some points, I'm not entirely sure why, but maybe just
okay. Shout if you lose me. I'll lean in a little bit, so you're going to get a close up. Thanks. So Ben Hall from Baringa, part of the team working on a couple of these tips with UKPN. You can probably pop straight to the first slide, Manu. So heat risers was looking at multi-occupancy buildings. So everything from high rises down through kind of more sprawling 70s, 80s kind of apartment developments, right down to converted flats, terraces, or big houses that have been converted, and the incremental challenges that arise. As we've touched on, the background policy assumption for heat decarbonisation is heat pumps, with that target of 600,000 heat pumps a year, which itself has some challenges in terms of things like upfront cost, the additional work that's needed in the house to enable the heat pump, etc., etc. But to UKPN, it was becoming apparent that multi-occupancy buildings or MOBs present further challenges. So as you start to put heat pumps in the buildings, you are sort of doubling or trebling the electrical demand of each of the flats versus what they use now on a planning basis. And as you do that, that can actually lead to constraints, not just on the electricity network, but the internal building network itself as well. So what gets called the rising and lateral mains. So risers being the big cable up the building and laterals being the cables that join to the individual flats. And what's starting to happen is that in some cases, a couple of customers will get heat pumps. And then when the third asks for a connection, the assessment is that the building can't actually take that and the whole network in the building needs to be uprated to enable it. That cost in the private sector at least would then be passed on to all of the customers, most of whom aren't engaged or wanting a heat pump yet. And so when they're presented with a £2,000, £3,000, £4,000 a flat bill for that reinforcement so that Mrs. Miggins in flat number 12 can have the heat pump, they say no. And so some of these projects then grind to a halt. And that, of course, is a risk and is a barrier. Part of the problem is that ownership of these networks is not always clear. So we know that over time, some DNOs have owned them, some haven't. And in the main, at the moment, they're not seen as a DNO asset to invest in. And so the cost typically passes to the customers themselves. Again, this raises a fairness issue. So both just due to the fact that if you happen to live in one building, you won't need expensive reinforcements, but if you happen to live in a building down the road where the network becomes constrained, you might. And so that can have quite a lot more cost on for those customers. So the question we looked at here really was to investigate what are the challenges, what are those kinds of costs, how many of these buildings are there, what types are they, how often will this challenge arise, and then actually look at the opportunity for thinking about whole building solutions instead. So an alternative to heat pumps on each individual flat would be to run the heat up the building itself in a heat network and just put one big heat source at the base of the building, so you avoid the need to run the power draw up the building. So we went in primarily with the question of, is there ever a case to avoid these internal building costs by putting a whole building solution in? And our thinking really evolved as we went through. The approach generally, the consortium was UKPN and ourselves, but supported by the Royal Borough of Greenwich, who are quite active in this in the heat decarbonisation space. DG Cities, who are a kind of innovation consultancy in the local authority space, looking specifically at heat, so a really great partner for this. And again, Passive UK, who are a heat control specialist operating in a number of different innovation projects across the space. So our approach was to first look at the customers and buildings, stakeholder engagement, segmenting the building stock, and then trying to get a sense of the costs. So it was interesting that data on this isn't reportable. We couldn't find any reportable data, so we had to start interviewing frontline managers, gathering case studies, which is always an interesting sign in an innovation project because it means no one's looking at it. We then looked at the solutions, so different types of multi-occupancy building solutions and the costs. Also looked at the route to market to those across the different tenure types. So part of the problem here is across social versus private and private rented, there can be multiple ownership types of customers in an individual building. And so if some of the flats are owner occupied, some are rented, it's very difficult to get all of those customers to make a decision all at the same time. And given the different options, we then looked at a cost benefit assessment as to what could the most cost efficient solutions be for certain building types. And then the question of how would we enable that. So I'll hand over to Hannah, who's going to take us through some of the findings, and then I'll just wrap up on some of the sort of conclusions and next steps.
Amazing. Could we go to the next slide, please, Manny? So for us to properly understand the problem space, as Ben touched on there, it was really important to understand the property stock in UKPN's area. So we looked through loads of census and English housing survey information to work out just how many multiple occupancy buildings there were. We and the census and English Housing Survey break down multiple occupancy buildings to be low-rise purpose-built apartment blocks. So that's anything 6 or less floors high, and also high-rise purpose-built flats, which is anything larger than that. And the final kind of like area was converted flats, which is basically like a terrace property, which was built as a whole house, but later converted into many flats. So they're really prevalent in places such as London. These types of properties make up 25% of housing stock in areas that UKPN serve, or 3.5 million dwellings. So if the problems of network challenges are going to be prevalent across a large amount of those building stock, it's obviously a really big area and a really big barrier for heat decarbonisation. So once we had an understanding of the scale of the properties in questions, we started having some really useful conversations with some of the area managers at UKPN about how common the building network constraints were, which turned out to be very in multiple occupancy buildings. The key factor alongside kind of like whether it's high rise or low rise or a converted building that affects the likelihood of those network problems were building age, with older buildings being more likely to have more and more extensive problems, which is highlighted in that bar chart, which shows that everything pre-19, 95% of that type of property are likely to have building upgrade costs upwards of £3,000 in order to enable heat decarbonisation. And the other like interesting kind of property characteristic that really affects whether it's going to need network upgrades is what current heating is used. So if they're currently electrically heated, then they're much less likely to have these internal building problems with their networks, because obviously they already are used to having the heat load on the electricity system. So as I said, that's highlighted in the graph, which shows that 95% of those pre-1919 high-rise buildings have a network cost upgrade of kind of £3,000 and upwards, which when you add that on to the already expensive, quite inhibitive cost of getting a heat pump, will mean that people effectively can't afford it. Which was reiterated to us by UKPN, who said that when these network problems were prevalent and being brought up in mobs in real life, these projects were then just being discarded because the costs were too high. So the additional complexity with multiple occupancy buildings is that if you have multiple owners within one building, it can become really unclear really quickly of who actually owns that internal building network. And hence the question arises of who is best placed to pay for the network upgrades, which generally is nobody wants to meet those costs. And as 69% of the high-rise buildings in UKPN's area are owned privately or privately rented, indicating that they have quite mixed ownership within one building, that's going to be a huge problem. It's worth noting that in social housing, the barriers could be slightly smaller because there is usually one owner, usually it being the local authority, and also communal level heating systems are installed more frequently, which could help to bring down some of the building upgrade costs, which I'll touch on in more detail in the next slide, if we could switch over, Manu. So now we'd worked out that individual heat pump installations are likely to cause all these network problems, we also wanted to see whether other heat decarbonisation tech could allow for some of the costs to be reduced. So one of the solutions we explored was a coordinated rollout of air source heat pumps, which is where an entire multiple occupancy building would be decarbonised for heating in one go, and therefore you could also upgrade the entire building network at the same time. Which enables, through buying heat pumps en masse, a reduction in the upfront capital for those technologies, which help offset some of the connection costs. And our lifetime cost analysis, which considered the upfront and running costs over 20 years, indicated that this solution was often the most financially viable solution to still allow for heat decarbonisation in these multiple occupancy buildings. However, you still have large barriers there of kind of getting the engagement with the community and getting the works done, and who meets the cost of the internal building upgrades. We also considered ground loops, thinking that they might be really great, where a shared ground array allows for heat to be produced slightly more efficiently, though these are really expensive upfront and still require the building upgrades because you still need a heat pump of the same size within each property, which means that they had a very limited benefit with regard to cost. The final solution that we looked into was heat networks, where one point electrical load within the building, rather than many electrical loads for your heat decarbonisation, could mean that the heat networks have much smaller electrical upgrades required or no electrical upgrades required. And the bar chart at the bottom right of this graph highlights that when the heat network does offset the cost of those internal building upgrades, that can bring them in a cost competitive place to the coordinated air source heat pump rollout. What's really important when discussing this analysis is that heat network costs vary hugely, as do these building network upgrades, based on all sorts of characteristics, which are really complicated and very specific to specific projects. And hence, we think that sometimes heat networks could produce even better financial results than presented here, but also could sometimes really be the wrong solution. And that's something we're really keen to explore as part of the next steps, which I think Ben will take you through on the next slide. Manu, if you want to click over.
Thanks, Hannah. So last slide. So just a lot of work's been done, but just to try and sum up very quickly, a bit of an eye-opener that most multi-occupancy buildings will require some form of internal intervention if you're upgrading from gas heating to electrified air source heat pump heating. In some of the older buildings, that can be quite considerable. We saw upwards of £3,000 per flat, and even more if you take into account substation interventions that can happen, some of which can be inside some of the large buildings. Given that upfront cost is already a barrier and this can add 30% more, we're seeing that being a tipping point. We've got a number of examples, as Hannah mentioned, of projects that have been shelved. I mentioned the fairness challenge in the intro, but some of the reason this has come up is customers beginning to raise complaints with the network around how they can't have their heat pump, but because others have already got them, and that's not fair. If you sort of play these challenges out and run the numbers together, we estimated that of the going back to the policy target of 600,000 a year, applying that to UKPN's patch, potentially 1 million heat pumps in UKPN's area could be at risk of not being installed at all. And we have confirmed that, yes, the route to market is very complicated and there are lots and lots of segments here. So it's not a kind of one solution fits all problem. In terms of the solutions, we started off with quite a focus on the multi-occupancy building heat solutions as a potential way to get over this challenge. And I think what we learned through the process is actually just uprating the internal building network to allow customers to install heat pumps in future is often going to be the most cost-effective solution for a lot of buildings. And so that is as important a question to look at going forward as the other. And the problem here is really that it's a case of investment ahead of need. When 80% of the customers in the building aren't interested or engaged yet, they're not likely to pay to enable others to have their heat pumps now. And so you end up in this catch-22 or this sort of block situation. So what's almost needed is an understanding more of the roles and responsibilities, how those interventions could be funded, and whether other policy support is needed such that we can actually equip these buildings to allow customers to take up heat pumps when they want, but without trying to force all customers to pay up front. So that's a really big, interesting question about intervention ahead of need. But there is still that case in 5–10% of cases for the multi-occupancy building solutions. But again, you run into the challenge of you need to convince an entire block to decarbonise at once. What's really interesting is that in some of the most expensive and complex solutions, it could even be the most cost-effective solution for the DNO to build a heat network and give it to the customers, rather than to do all of the consequential network reinforcement that they would have to do and charge back to customers. And that really needs a bit of extra investigation, because it could be, even from the perspective of the DNO's TOTEX incentive, it makes more sense to go and decarbonise someone's heating than it does to reinforce the network to enable the next connection. So some big questions there. And so in the next steps, what we think is really important here is to understand and tease out the factors that go into this decision and build a decision-making framework that allows you to identify the optimal answer on a building by building basis, almost a toolkit that allows you to say, well, we all agree that actually this is the most cost optimal solution, and use that as a way to inform what the right policy answer should be. So that would need to be done with, with Ofgem, with industry stakeholders, with the DNOs, with participants, and would need a much better understanding of, in specific building scenarios, the costs, the solutions, etc. We think we should also look at the options for addressing the building network upgrades. So who pays, who should own that part of the network, and how could that be funded? Does it need some form of government funding support, or should it be a role of the networks? And then looking ahead to beta phase, we'd like to take this on to a learn by doing approach, where this is a very complicated problem and it needs more theoretical understanding. But then we think at that point, it would be good to attempt to decarbonise a set of the more complicated buildings with more complicated tenure types, and learn by doing, sort of mapping out the different interactions, testing the theory, and understanding to what extent you can engage customers to decarbonise all at once, rather than one at a time over time. That's the end of the slide. Thanks, Benny.
Brilliant. Thank you so much, Ben. Thanks, Hannah. Great presentation. I think a really good example of kind of, if you look at kind of bottom up for the heat decarbonisation challenge, there are risks that some segments get left behind, or it's too expensive to decarbonize. So really like unpacking that, and then putting some quite difficult questions on some of the things that you said, Ben, around actually cheaper for the network operator potentially to kind of build, operate, and transfer off a heat network rather than reinforce. I think opens up some quite critical regulatory issues as well for us to kind of think about how to decarbonize. So I think we've run out of time in terms of Q&A. So if you don't mind, Ben or Hannah, there are a couple of questions and comments, I think, from Maxine as well. If you can maybe just address it there, I'll kind of wrap up the session. But thank you so much again for the presentation. Really, really important project, I think.
Thanks.
Thank you. So if we move on to the next slide, please. So I think this kind of ends our session today. So I think, really, really, fascinating set of kind of projects looking at the quite difficult and critical heat decarbonization challenge. So, these kinds of projects kind of interest you. We've got a few more coming up tomorrow, looking at decarbonization of transport, but a multi-vector approach. And then kind of next week, looking at just transition, local energy systems, and kind of robustness of delivery of net zero gets covered. So the links will be put on the chat, I believe, and you can kind of register. And one other, I think, slide we have, which is just to a shout out that we're also going to be running, maybe not. Well, anyways, I think we're going to be running kind of webinars as well for people looking to develop applications into SIF, but potentially might kind of lack some of the energy kind of system and knowledge. So we're going to be running a series of webinars to kind of upskill potentially innovators or others who may have ideas, but maybe want to understand the broader context to contextualize their innovation. And so please do look out for that. Otherwise, I think what remains is to thank the speakers, the networks. I think it takes a lot of prep to do this, and you've heard the amounts of work that's kind of gone on. So really appreciate you coming on and presenting and taking questions. And thanks to everyone who kind of joined in as well and asked questions. Hopefully you found it a productive session. Thank you so much, and enjoy the rest of your day. Enjoy the sun. Take care.